is we have to first of all create the line. So we are going to write here that our line equals, so this value should be actually there's image region coming here. Let's remove that because we don't need that anymore. Now this line, I have checked the values already, so we are going to put that, let's call it limits. Let's call it limits instead, and then we are going to write here 423, 297, 673, and 297. So these are the limits, and using these limits, we are going to create a line. So this line, let's draw it after the tracker. So here we'll write cv2.line, and we'll give in the image, and then we have to give in the points. So the points are basically limits at 0 and limits at 1. Then the second point will be limits at 0, limits at 2, and limits at 3. And then what do we need? Then we need the color. So the color, let's put it as red. So it will be 0, 0, BGR, so 255. And then we have the thickness, let's put it as 5, and that should be good. So if we run this now, we should have a line right in the middle of our road. So there you go. So this is our line. If these IDs, if any of these cars, they cross this line, then it will be detected as detection. Actually, what we can do is we can extend it to the left a little bit because there's a gap here. So let's go over here to the limits, and in the X we can make it, let's say 400. We'll move back 20 pixels, 23 to be exact. Yeah, now it's perfect. So now it should be fine. Now what we need to do next is let's remove the detection part. So we don't need to draw the rectangles when we are detecting, only for the tracker. So here the corner rectangle, we can remove that. So now it will only show us the blue ones. There you go. Now it's only showing us the blue ones. Actually, I like the purple color better. Let's make it purple. 255 and make this 255 as well. So now the rectangles will be purple. There you go. So yeah, I like that better. So the next step is to find the center point. So once we have those center points, we need to check if that center point actually touched this line. If it touched the line, then we are going to say it was a count. So that's the idea. So how can we find this? This is our results. We have the X, we have the Y, we have the width, we have the height, we have everything. All we need to do is we need to find the center. So we will call it CX and CY. This is the center X and the center Y. And how can we find it? It will be X1 plus the width divided by 2. And it will be Y1 plus the height divided by 2. So just to make sure that we are headed in the right direction, we can draw it. cv2.circle, and we'll give in the image, we will give in the CX and the CY, and then we are going to give in the radius. Let's give it 5. I don't know why I'm giving everything 5 today. So then we'll give in the color 255, 0 and 255, purple again. And the thickness, let's put it as cv2.filled. So we want it filled completely. So just to make sure that the circles are at the correct position, we are going to draw them. And there you go. So here you can see the circles. And as soon as this circle actually falls in this region, we are going to count it as detected 1. There you go. So how can we do that? We can write that if we need to check the limit of the x and we need to check the limit of the y. Now the limit of the x is straightforward. We have starting from here, ending till here. It should be within this region. That's simple enough. So we can write that the limits at 0, this is our first limit, and the limits at 1, no, at 2, this is the second limit. So x and x, these are the two limits. So the first one is 400, the second one is 673. So that's the idea. So we are going to say that if Cx is in between that and Cy is in between what limit? Now, we don't want to say if Cy equals the exact value of our limit. No, we don't want to say that because this is just a single value. The height is a single value, 297. So we don't want to say if the value is exactly 297, then detect it as a count, because sometimes the car may be fast and it might not touch that pixel value. So putting it as one pixel value might be a problem. So what we need to do is we need to create a region. So this is our line. We will have this region. Can you see? Yeah. So you will have this region in which if it lies, then it is detected as a count. So what we can do is we can simply write that limits at 0, at 1 plus 20, or for this instance, minus 20. And for the next one, we can say plus 20. So if it falls in that region, then only it will detect it as detected. So then we are going to say that total count plus equals 1. And we didn't define total count, so we will write here, after tracking, we will write here total count equals 0. So total count plus equals 1, and all we have to do is now we have to show the total count. So let's copy this CVZone function. We'll put it on the image. We will write count and colon, and then we will write total count. It's already integer, so we don't need to worry about that. And we will give in the value of x as let's say 50 and y as let's say 50 as well. So 50-50, and the rest we will keep at default. What happened? Okay, so let's run that. There you go. So the total count right now is 0 because nothing passed that region. So if we keep pressing, and there you go. Now it entered that region and it counted as 1. But now you will see an issue. If I press again, it counted it as 2 because it is still in that region, because it's not just a single line. It's a region where it lies. So because it's already there, it's counted it as 2. Now, if we make this region very small, it might not count it at all because it's very low. But if we make it very big, then it will have multiple counts. So we need to have a balance. First of all, we need to have the balance. And the second thing that we do need is we need to check if this ID is already counted or not. If it's already counted, we will not add it to the counter. That's how we will fix this issue. Because if I run it again, at the same point, it has counted 3 times. So that's not good. Okay, so how can we do that? Instead of making it a variable, we will make it a list. I'm talking about the total count. So instead of making total count a variable, we'll make it a list. And in that list, we will put IDs. So 1, 2, 5, 8, 9, things like that. So then whenever we detect a new count, we will check if that ID is already present, we will not count it. If it's there, We will not count. If it's not there, we will add it. Okay, so how will it look like? So total count, we will make it a list, and then we will go down, and here we will say total count dot append, and we are going to append the value of the ID. Okay, but how can we check if it's already there or not in the total count? We will check, we will write if the total count dot count of the ID equals 0, then do this. Now what does this mean? So basically we are telling it to find the number of times. When we write dot count, it means count the number of times this ID is present in this list. So for example, if it was 5 here, it will count the number of times 5 is available here. If 5 is not available, it will be 0. If there were 2 5s, it will be 2. And then if there is no 5, it will be 0. So this is what we are saying. So we are saying if this ID is not already present, then total count dot append ID. So this time it should be correct. But now it is a list. It is not an actual value that we can just write here. So all we have to do is we have to find the length of this list. So that will be the total count. So let's stop that and run it again. And this time around, if we click, this is count is 1. Now if I go to the next frame, it should not count. There you go. It didn't count. If I go again to the next frame, it should not count. Didn't count. Now it should count because that's the second ID. Then it should count third ID, fourth, fifth, sixth, seventh, eighth, and so on. So if you see that some of the detections are missing, what you can do is you can increase this value. You can make it 30, because right now we have another check that is checking whether it's a duplicate or not. So we don't have to worry about that. And the second thing we can do is we can change the color of this line. We can change the color of this line so that whenever it's detected something, it turns green. So it's an indication that it had a count. So we can print it maybe here at the end, or we can simply print it again in red color. I know it's a weird way to do this, but you can do this. You can just simply print it again, and instead of red, we'll print it as green. So it's basically overlaying on top of it. Okay. There you go. So if we run this now, at this point, it is detecting as a count because it's within that region. And then it's detecting, maybe it's too early. Okay, maybe it's too early. Let's reduce this to 20 back, or let's put it as 15, and let's put this as 15 as well. Yeah, I think that's better. 2, 3, 4, 5, 6, that's correct. Then 7, that's correct. Then we have 8, that's correct. 9, this will be 10, this will be 11, 12, 13, 14. So it should be 14 till here. Then 15, 16. It should be 16 when it crosses these all. 16, that's correct. Then 17, 18, 19. 17, 18. That was 19. Then 20, 21. It should be 21 after this. This is 22. Okay, this is getting confusing. That's why we have the computer to actually find it for us. So what we can do now is we can go down and we can put it as 1. And let's see the magic happen. So there you go. It's really fast and it's detecting all those counts. And of course it's using the GPU, that's why it's so fast. 62, 63, 64, 75, blah 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 blah. So that's good. So so now everything seems to work fine, but what we can do next is add a little bit of graphics so that it looks a little more appealing. So I have a graphics file here. Again, you can find it on our website within the zip folder. It's free to download. Just go ahead and download. So this is the graphics.png. We are going to overlay it on our main video, and then we are going to display the numbers on this. So how can you do that? We are going to read this file. We are going to say image graphics equals cv2.imread. Now, the reason we are importing it within the while loop is because if you don't do that, the graphics quality will be really bad over time. It will give very bad results. So you have to import it every single iteration. So graphics.png, and we will write cv2 dot unchanged, image unchanged, imread unchanged. So you have to write that, otherwise it will not work properly because we are going to remove the transparency. So then what we need to do is at the very end, we can overlay the image, or yeah, we can overlay it over here as well. It doesn't matter. So here we are going to write that cvzone dot overlay png. So image, the first one is the background, or the first one is the background. So this will be image, and the second one is our image graphics. It will overlay. And where is the position? The position is 0, 0. It's right at the corner. And we will put it back to our image in the main file. So let's run that and see if it's in the correct position. If it is, then we will overlay the count on it. There you go. So now the image is there. Looks good. And now we will remove this rectangular count. And instead of this count, we are going to simply write cv2 dot put text, and we are going to write the image. The text will be basically string of the length of the total count. And then we will have, what do we have next? The origin. The origin, let me check. It should be 255 and 100. Then we have cv2 dot font Hershey plain, and then the font scale, let's put it as 5. The color, let's put it as black, or let's put it as red. 50, less red, 50 50 255. And the thickness, let's put it as 8. So let's run that and see if it works. And there you go. So now you can see the count. It looks really good. Tuck, 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 tuck. So normally you won't be able to count it this fast. So finally, the robots or the AI is helping us solve problems. So this was our project for car counter, and it was a really simple, and as you can see, it's very fun to do. And it is very informative. So I will see you in the next one. So now that we have completed our car counter project, we are going to do a similar project to that, which will be people counter. So the difference between car counter and people counter will be that we will have multiple directions that we are counting in. So if we go to our video people, people.mp4, and we have a look at the mp4, you can see that we have an escalator that has two directions. One is going up and the other one is going down. So there are people going down, there are people going up. So we are going to count how many people went up and how many people went down. So that will be the task for this project. So what we will do is, first of all, we will copy, which is the best thing ever. We'll copy and paste our complete project. Now, what this will allow us to do is to use our previous code, and we can adjust it to our new video and our new purpose. So we can write here people counter, and this is project number 2. So we will hit OK. So project number 2, people counter. First of all, we will open it up and we will rename it. Where is the rename? Here is the rename. So we will write here people counter. There you go. So we'll write people counter here. We have sort, mask, and graphics. Now the mask and graphics are going to change, but for now, just to make sure everything works fine, first of all, we are going to change the video. We will write here people, and then we are going to run it to see what happens. So as you can see, we are still using the large version. So there you go. So we have the graphics over here, which is for the car, and we have a line here which is basically counting. But as you can see, it is not counting anything because it's not detecting anything. Because if you remember, we asked it to only detect cars, bikes, trucks, and motorbikes. So those are the 4 classes that we want to detect. So that is not being detected here. That's the first thing. The second thing is that we have the mask, which is being overlaid in the wrong place. We need to remove that too. And then we also have the counter or the graphics, which is wrong as well. So first of all, let's bring in the graphics. Again, you will find the graphics in the zip file when you download it from our website. So I've created this earlier, and this is how it looks. So this is the graphics. So what we can do is we can simply replace this graphics right away so that we have one less thing to worry about. So here in the graphics, we have graphics.png, and we will not put it at 0, 0. What we will do instead is, let me check the exact values. It's 730, 730, and 260. So this is the exact position where it should be. So if we run this now, we will have the graphics being shifted. There you go. So we have the graphics over here. So that is the first thing done towards our people counter project. Then the second thing that we can do is we can open up the detections for people. So here we have car, and here we have the confidence. So the confidence will keep the same. The rest we will delete. And we will write here person. If the current class is person and the confidence is greater than 0.3. So now it should give us the detections, but we will have the issue of the mask, because as you can see, the mask is around here. So it's only detecting in this region. So the mask is completely wrong. So what we need to do, we need to go ahead and create our new mask. So let's go ahead and do that. So we are back here in Canva. And as you can see, it's the same file. We had this mask earlier, and now we are going to create a new mask. And this is the same video that we saw earlier. And first of all, we are going to fill it up in the space. And now we are going to start creating our mask. We can go back and simply copy one of the rectangles so that it will be easier for us to work with. So here we will rotate it like that. Maybe a little bit lower. There you go. I think that's good. We will copy that and we will paste it here. Okay, it's not straight. It's not aligned with the escalator. So maybe around like that. So let's play the video so that we can see till what points do we get the people coming in out. There you go. So I think, yeah, maybe a little bit lower and maybe a little bit tilted. Why does it start in the wrong position? There you go. So yeah, I think that should be fine. And we can remove this because this is correctly aligned, and we can paste it here. Oh no, the angles are different. Okay, so we need to rotate it again. Maybe like that. And we will put it here. There you go. So this should be our new mask, and we can push this back here. And we will delete this video so that it becomes white. We need to fill this gap. There you go. So we can download this mask. Now we need to select which page. We're talking about page number 2, and we don't want any transparency or any compression. and now it's downloaded. So we will drag it in our people counter and we will write here mask. The reason I'm showing this is because if you have a different video or if you are working on a different project, you can actually do it yourself. Otherwise, for me to just copy and paste is very easy because I've already done this, but I'm showing you this so that you can do it yourself for your own project as well. So this is the mask, and now let's open up the region as well so that we are 100% sure that it is working as we expect it to. So there you go. So this is the mask, and as you can see, it is detecting very well. So 1, 2, 3, 4, 5, 6, 7, and now we need to fix the counter. So how many people are going up and how many people are going down? So in this case, we will have two lines. So we don't have just one line, we will have two limits. First of all, let's comment this out and we will go up, and in the count or in the limits, we will have two of each. So we will have limits up and limits down. Limits down. And then we have total count up and total count down. So we need to put the lines here. So I have the lines for up. It is 103, 161 and 296, 296 and 161. And then for the limit down is 527, 489 and 735 and 489. 735 and 489. Yeah. So yeah, that's good. And here we have limits, because now we'll have some errors because limits is not actually there. So what we can do is we can comment all these errors. We can comment this. Control and slash is how you comment, and then we will comment this as well. And anything else? No. Okay, so now that this is commented and we know there will be no errors, what we can do is we can change this line, for example, to limits up, and we can write here up and up. Why am I writing it wrong? Up and up. Okay, and then we will write again for the other line, we will write down. Limits down, and I'm going to copy it so that I don't have to manually write it again and again. Okay, so let's run that, and hopefully we will have two lines, one for going up and one for going down. There you go. So this line is for going up and this line here is for going down. So we need to check for both of these individually, how many people are crossing that line and how many people are crossing that line. Okay, so then we will come to the limits. So here, let's do for one. So instead of limits, we will write limits up. See how lazy I am. I'm going up just to copy it. So limits up, I'm going to paste everywhere. You can actually do a search and replace, but again, you see how lazy I am. Okay, total count, we will put up. Why I don't know why. Okay, total count up dot append id and blah blah. And here in the put text, we are going to write up. Okay, so let's run that and let's see what kind of results do we get. Are we getting anything good? Because it is supposed to be, get green. Yeah, so there you go. It went green. 1 count, 2 count, and 3 count. There we go. And 4 count. Excellent. So this is working fine. All we need to do now is take that and put it down in the correct region and make it green instead of red. So let me check the values. Exact values for the count is 929 and 345. 345. And Hershey Plain 5 and 7. And this should be 139, 195 and 74. So we are giving it a bit of a green color. Green is for up, red is for down. So there you go. So here you have 0. So the first one goes, so you get 1, and then the second one is 2, and the third one is 3. So now we need to do for the people going down. Okay, so for the people going down, it's very simple. All you have to do is you have to here the if condition, copy that and paste it, and instead of up, now we are going to write down, limits down. So if we go down, and here we'll write down, 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 down. Okay, and then we have count up, so that will become down. Count up will become down. We will copy the text, and here the values are 1191 and 345, and the color will be 50, 50, and 230. So this should be total down. So let's run that and see if it works. There you go. So we have the red part here, the green part here. So this is going up, 1, 2, 3, and now it should detect these two as well, 1 and 2. There you go. So we have a total number of people, 4 people going up, and we have a total number of 2 people going down. So again, if it was crowded, it will detect all the other people as well, and it will do the calculations. So as you can see, it's very easy to actually change the code a little bit and cater it to your own project. And it is very fun to play around with these values. And because this is something that you can implement in real time, and it is something you can implement it as a real world application, that's why it's really informative and fun to do as well. And in the next part, we are going to learn how to create your own custom model. So you can create your own data set and use that data set to train your model. And using that model, you can create your project. So that is what we are going to do next. So let's go ahead. So now we have already studied and already learned how actually we can use pre-trained model to create our projects. But now we are going to create custom trained models with our own data set, and we are going to use it in our projects. So how can we do that? So we can do that by using either NVIDIA's graphic card, or we can use it by running Google Colab online. So we will be using Google Colab since everyone has access to it and it's free to use. And if you have your own graphics card installed, you can do pretty much the same thing offline as well, pretty much the same code to run it on your own PC. So here we have a Google Colab opened up, and it's called YOLO version 8. And right now it's empty. And what we have to make sure is that the runtime is, if you go to change, we have to make sure that the runtime is GPU. We are going to save that. Now, before we actually go and write some code on how to train your custom model, we need to know what kind of data set that we need. So the project that we are going to do today is called the PPE detection, or the personal protective equipment, basically the hard hat and the construction jacket and the mask. So we need to find whether a person is wearing that or not. So we have this data set available on RoboFlow, and you can see we have the version YOLO 8 as well. You can simply download it from here. So if you click on that, and you can download zip to computer, and you can press continue. Now, by doing this, what will happen is that you will get the data set as well as the YAML file that will allow you to run with YOLO version 8. Now, if you don't have a data set available online, and if you wanted to create your own data set, then you actually need to know what is the format in which the data set should be. So in order to understand that, we are going to open up this construction data set. So here is that data set. If you download it in a zip format and if you extract it, you will have test, train, and valid. These are the three folders, and then you will have a data file. So in the test file, you will have images and labels. In the train file, you will have images and labels, and valid also images and labels. So if you open up test file, if you open up images, you will see all of these different images that you have, and each image will have a corresponding text file. And in that text file, you will see all the different classifications. So for example, you will find the class number 8 at these coordinates. So these are basically normalized values. It means they are from 0 to 1 in between those values. If you multiply it with the actual image size, you will get the pixel values. So these are the 4 values, x1, y1, and the width and the height. So you can find all these values for all these different classes for all these different images. So if you go to, for example, train, you will find images, and within these images, you will find these labels, and within the labels, you will find all these corresponding coordinates. So this is the file format, and then the important thing to have is the data. So the data YAML file, basically it gathers all this information into one place, and if you open that up, you will see that you have train, validation, and test folders. So you have to mention where these folders are. And then you have the number of classes that is equal to 10 in this case. And you have the names of all these classes. So you have hard hat, mask, no hard hat, no mask, no safety vest, person, and safety cone, safety vest, machinery, and so on. So, and the rest of this is not very important. This is just for the copyrights and all that. So what you can do is, and there's one more thing we need to add when we bring it to Google Colab. So what we will do is we will copy all of this data to Google Drive. So if you go to my drive right now, I have a datasets folder, and within that dataset, we have construction safety. So this is the exact same folder. You can see here. You can see here construction safety. So you have readme, and then you have the data.yaml, and then you have the test, train, and valid. These are the 3 folders. If you open that up, each folder will have labels and images inside of it. There you go. So this is the basic idea. If we go back to our datasets, construction safety, and this is the main thing. So here data.yaml, we have to make some changes here. So here in the file, you'll go to the text editor. If you remember, here our file contains train, validate, and test. These are the folders that we have. But we need to define the path where these are present. So we have to write here path, and then we have to define the path in our drive, in the Google Drive. So that is what we have done here. So you will open that up, and you will write here path, and inside that you will write drive, my drive, and then whatever your folder is. So for me, inside my drive, I have the folder datasets. Inside that, I have the construction safety, and inside that we have train, valid, and test. So you have to write this path. The rest of it remains the same. So this is the basic idea of how you can upload your files to Google Drive, and how you can edit it to run it using Google Colab. So that's the only thing you have to do. You have to write here path, and you have to give in the path file. I will show you it. I will show you this again once we go into our Google Drive. Okay, that's done. But what if you have your own images and you want to create this, if you want to label it, what can you do then? Now to do that, we have a very famous label img project that is available on GitHub, and you can see it is by Heart EX Labs. So thanks to all the contributors and the creators. So what you have to do is you have to go to the releases. You can click on binary, and here you can download the zip file. Once you download the zip file, you can extract it. And once you extract that, you will get something like this, label image.exe. Now, for example, if you were to find the poker chips, if you were detecting poker chips, here in the data, you will go to predefined classes, And here I have given 5, 10, 20, 50, and 100. These are our 5 classes. In case of construction safety, we have hard hat, no hard hat, jacket, no jacket, and stuff like that. So you will do that, and then you will go back and click on label image.exe. Once you open that up, you can open directory. You can select, for example, these are the images I want to label or whatever. So for example, these are the images. So then you can press you can press W to actually select, and you can define, for example, this is class number 5, and hit OK. So this will create this label. Then you'll press W again, and this is, for example, for 100. You'll click on 100 and press OK. Now the easy way to do this is do all the 5s first, then all the 10s, then all the 100s, all the 20s, things like that. And once you want to export, you will make sure that this here, it's YOLO format, and you will click on save. And here it will save the file. If you hit save, it will save the file in that location. So if we open the directory, so here we have this directory. So let's say we save this one. So if we open that up, you can see it's the same format. So 0 is for, I think, 5. That's for 5. So the location of this is at this point. So these are the coordinates for that. Then class number 1 is present here. Class number 2 you have here, and so on. So this is how you can label these images. So the data.yml file you can create yourself. As I've mentioned, it's very easy to do. All you have to do is you have to write the path, the train, the validation, and the test folders. And then you have to write number of classes and the names of the classes. That's it. And you will save the file. It's a simple text file, basically, by the format .yml. So once you have done that, now we can simply go ahead and upload everything. For example, in this case, we can download it from here, the construction safety image dataset. And once we have that, we can upload it to our Google Drive. Once Google Drive, these are basically the files. We'll select all and drag, but I will not do that now. Then once you have that, because it will take some time, then we have YOLO version 8. This is our Google Colab file. So what we have to do is, first of all, you will go to folder, and here in the folder, you will see that we have an option here to connect your drive, mount drive. So make sure you click on that, and it will mount your drive. It will ask you to give access. Once you give the access, this will have a cross. It means it has been mounted. So if you go back and you click on content, not the bin, the content, I think it's still loading. Let's wait for it. Content, there you go. So now you have the drive. So if I click on the drive and then my drive, and then I can go to datasets, and inside the datasets we have construction safety, and inside construction safety we have test, train, valid, and data.yml. If we double click that, this is what we have to make sure. So this path should be correct. So if I right click here, let's say construction safety, if I right click and I can say copy path, and then I can paste it here. So this is the path that we need to have. Content drive. So after content, we need the drive. So from drive, we are going to write my drive datasets construction safety. So this is what we need. So we need to make sure it is at the path over here. So once that is done, we can close this, and we can close all of that. And now we can start writing some code. Again, just make sure the runtime is GPU, and we will save this. And over here, we are going to, first of all, write a few lines of code. That's it. We will need 5 lines of code, and we will have our YOLO running, and we will have our YOLO training. So first of all, we need to check whether we are using a graphics card or not. So we will write here NVIDIA SMI dash SMI, and then we are simply going to run it. So once we run this, we will have some information. So here you can see Tesla T4. We are actually using 153 60 MBs. So that's good. So we are actually using a graphics card. So that's done. Now what I like to do, I like to clear all the outputs whenever we do that. So then we can write another line of code. Now in this, we are going to install Ultralytics. So we will write here pip install Ultralytics, Lytics, Ultralytics. We will hit enter. Oh, sorry, we'll hit play. So now it's done installing. So that's done. Again, I will go back to edit and clear outputs because I don't like them. Then we are going to go and we are going to import YOLO. So like we did earlier, from Ultralytics import YOLO. YOLO is capital. And we are going to press enter. And there you go. It has been executed. So now we are going to write the actual command that will run YOLO and detect it on an image. So first of all, we are going to write YOLO, and then we will define the task to detect from an image. We need to detect objects. It also has the option of classification, and it also has the option of segmentation. But for now, we will just do detection. You can write segmentation as well if you wanted to segment. Then we have mode predict. There is training as well. There's validation as well, but right now we are using the mode as predict. Then the model. So which model we are using? We are using YOLO 8 version, YOLO version 8, which is large. So we are using the large model, and the confidence level minimum should be 0.25. And what is the source? The source is basically the image. So it can be here in your drive, or you can give an online source. So for now, we are just giving it an online source. This is basically ultralytics.com/images/bus.jpg. If you had your own image, you can import it here and test it out. Or if you have an image online, you can test it from there as well. So once that is done, this is the moment of truth. We will press enter, control enter, and then it will execute this command. So first of all, as always, it is going to download the weights because it already does not have that. That is done. Now it is running and it is using CUDA 0 Tesla T4. This is the GPU that it's using. So that's good. We know that it's working. It's downloading the image, and the image has been downloaded and it has executed everything. So as you can see, this is now done, and you can see it downloaded the file, and then it gave us the result that there were 5 people detected, 1 bicycle and 1 bus. So if we open this up, it will not actually show you the bounding boxes and all that, but we will need to write some code for that. But for now, you can see there's 1 person here, 2nd here, 3rd here, 4th here, and maybe a 5th inside, well, over here. So 5 people, 1 bicycle, 1 bus. So this is the bus. I'm not sure where the bicycle is though. And yeah, so that's the idea. So it means it is working. So what we need, we don't need to test any images here. We can run it on our actual offline code, and we can write the same code here and it will work fine as well. But we just wanted to check whether it's working or not, whether the installations are working or not. So once we have confirmed that the installations are done, what we need is a simple 1-line code to actually do our custom training. Oh, custom data training. So that's it. And then what we will do, we will add our code, and I'm going to paste it here. So now we have a similar command like before. We have YOLO, then we have task, again we have detection, but this time around the mode is training, not prediction. It is training, and it is training based on, again, the large, what do you call the model, you can use the nano, small, or medium as well. And where exactly is the data? So this is what you have to define. This is what you have to change. So data basically equals double dot slash content drive. So this is the exact path that you will copy and paste here. So double dash back, double dot back, content drive, my drive, datasets, construction safety slash data dot YAML. So you have to give that file. That file is the linking file for all the dataset. So you need to give the location of that file. Then you can define the number of epochs and the image size. So that's pretty much it. And now all you have to do is press run and see the magic happen. So it will take a while to actually train. So we will let it train and then we will come back to it. So first of all, it is setting up all the weights. Here you can see 589 of 595 items from pre-trained weights. So we are using the pre-trained weights to actually train our own model. You can say it is transfer learning as well. So the optimizer has a learning rate of 0.01. And let's see, when does it start? So there you go. So right now it has started. So this is epoch number 1. Did it start? Not yet. Let's wait for it to start. So now you can see the epoch has started, the counter has started, and here you can see the time that has taken already and the estimated time that is left. So this is basically the idea. So each one of these will take, for example, 2 minutes or 3 minutes. So you can calculate from there. It will take, for example, 150 minutes. So anyways, let's wait for it to finish and I will see you once it's done. So now you can see that the process has completed, the training is completed. And if you go to runs, this is basically in our content. If you go to runs and in detect, you go to train, you will see all these files generated. So the main thing that we need to look at is the best.pt. These are the weights, and this is the last weight.pt. So and the rest of these are basically the parameters, the response of our model. So for example, you can see over here results.png. You also have the so here you can see the mean, average, position values, and you also have the recall and the precision values, and you have the training loss for the class and for also for the box. And then you also have the confusion matrix. So all of these things you can download. You can click here and download. It will be easier to see. Otherwise, you can open it up on Google Colab as well. So here you can see the confusion matrix of how well it responded to the training. So then what you will do is you will download the best file. And once that is downloaded, you are going to bring it to our project. So here we are going to name our projects. So we will copy YOLO with webcam, because that's pretty much what we are doing. We are running it with webcam. And what we will do is we will remove all of this and we will write project 3. And here we will write PPE detection. So this is our project 3 and it says YOLO webcam. So we will double click that and right click and rename, and we will write PPE detection. There you go. So now what we can do is we can use the PPE videos. So if we go here, we can open in our Explorer and you can see we have these 3 videos. This is the first one. This is the second one. And this is the third one. So we are going to test on all 3, and we'll also test on the webcam. I do have a hard hat, and I'm pretty sure we can find a mask, and I also have the construction jacket, so maybe we'll try that as well. So let's write here PPE -1. I believe that's the name, And yeah, that's good. And then we have to change the model. So here we are just simply going to drag and drop. So here, this is the model. So we are going to drop it here and we are going to call it PPE. So here we will change it to PPE and we will remove all of this. So let's go ahead and run it. So let's actually, one more thing I forgot. We do have to change the class names. So if we open up our files that we got, the data.yml file, we have the names of all the classes. So we can simply copy it from there. So this is in the data.yml file and we can replace it with our class names. There you go. So these are the class names, and now if we run it, it should work fine. There you go. So it's detecting the person, it's detecting the hard hat, no mask, and you can see it also detects safety or no safety vest. So it's not the most accurate, but it is giving us some good readings. So what you can do is you can train it with more data set and for longer epochs, for more epochs to get better results. So here you can see safety vest, no mask, hard hat, and person, hard hat, no mask, and there you go. Let's try for number 3. There you go. We have safety vest, hard hat, person, no safety vest. Here we have no mask, safety vest, hard hat. Okay, so what we can do is, this is a little bit difficult to see what exactly is being detected or and what's not being detected. So what we can do is, we can check which classes are we detecting, and based on that, we can assign a color. So here we can put a normal rectangle, or do we need to put, yeah, let's put a normal rectangle instead of the corner rect. So we will write here cv2 dot rectangle and image, and we will give in the x1 y1 and the x2 and the y2, and then we are going to give in the color. So this will be my color, let's say my color. So by default, my color equals red. So 00255, and then we are going to write down the thickness. Let's say it's 3, and that's pretty much it. So, and then for this part here, put text rect. We are also going to assign the color for the rectangle, or color for the background, and color for the text. So the color for the background, let's make it my color, and for the text we have to make it white. Color for the text, we are going to make it white. So 255 to 255 and 255. So let's run this and see what happens. Oh, we need to remove the corner rectangle. So what we are trying to do is that it should detect, it should show us the red color, and in the case where there's no mask or no hard hat, and in case it is present, it should give us green. So okay, so yeah, now it's my color is showing, but it didn't show for the put text rect. Let's put it for the color rect as my color as well. Yeah, now it's good. So it's showing red for all of these. So now we need to make sure if by default it will be red. If we are detecting one of those classes that have the green, then it should detect green. For example, we have the hard hat, we have the mask, and we have the safety vest. So these are the three classes. So what we will do is we are going to check. First of all, we will write here current class equals class names at CLS, and if current class equals hard hat, is it capital? Yes, hard hat, then my color equals 0 to 55 and 0. Let's try that out. So now all of them are green. So what's the issue? If current class equals hard hat, my color is 0 to 55. Current class is coming from here. Put text, and we need to give it after. So the rectangle, because this has my color, needs to be here. So we will put it here, and current class equals hard hat. Hard hat. Why did it show all of them green? That's weird. Let's print the current class. So when we are printing the current class, it shows person, safety vest, safety vest, safety vest. Oh, we need to write else. Else, because it's not changing after that. My color equals 0, 0, 0, and 255. Now hopefully it will be better. Yeah, so there you go. We have green for hard hat and the rest are red. Okay, so if my current class is hard hat, or my current class is safety vest, safety vest and mask, or my current class equals mask, then it is this. Otherwise the rest of them are red. And what else can we do? We can make it smaller because scale is not that good. We are using the put text rect. We can make the scale 0.5, let's say, and the thickness is 1. That's fine. And the offset, let's make it 5 instead of 10. So it will be a little bit smaller so that it's easier to know what is going on. There you go. There's a lot of overlap, that's why it's a little bit confusing. But you can see that when it's the hard hat is detecting, it's showing us green. When it's not, it's showing us red. Let's try it. Actually, the scale is very small, so let's try one, and let's try another video. The first one was the most clear. Let's try that one out. There you go. So we have the hard hat, we have the person, no mask, and safety vest. Or what we can do is we can assign a third color as well, because if it's a person, then we don't need to worry about that. So all the red colors and all the green colors, and then we give an else. So if it's current mask and all of that, then we can write else if, and then we can write else my color is purple, or let's say blue. 255 0 and 0. Okay, so it's no hard hat, and no safety vest, and no mask. Yep, these are the ones for red. Then safety cone, safety vest, we don't really care about that. The rest are blue. So let's run that. So the person now should be blue, and we should have green for, okay, it's opposite. Hard hats, safety vests, and we also need to give in maybe a threshold so that we don't get a lot of wrong detections. If the confidence level is greater than 0.5, let's say, then only we'll do all of that. So yeah, we were talking about the color. So no hard hat. All of this is supposed to be red. These are supposed to be green. So, and the rest are blue. Let's run that again. There you go. So we have the safety vest, safety hard hat, and the person, and then we have the no mask. So when it's not very clear, it's not giving good results, but overall it seems to work fine. So now we can also try it with the webcam. So I will put it, okay, let's keep it for video, and for webcam we can open this up and let's try it out. So as you can see, I'm not wearing a hard hat, no mask, and no safety vest, but it's detecting the person. So if I wear a mask, you can see it's detecting the mask. And if I wear the hard hat, you can see it detects the hard hat. There you go. If I remove the mask, it says no mask. There you go. And we have the hard hat and no safety vest. So now we are headed to project number 4, and in this project we are going to create a poker hand detector in which we will first of all detect all the different cards, and once we have the cards we are going to determine what poker hand do we have. So this is a very interesting project because it has multiple layers, and the first one is to actually detect the cards, which we will do by YOLO, and the second one is actually classifying what hand do we have. So there will be a little bit of code involved there. So where are we getting the data from? The data is available on RoboFlow Universe, and we are downloading the playing cards image data set, and we will download the YOLO version 8. So you can simply click on that, download zip to computer, and you can press continue. Once it is downloaded, you upload it to the Google Drive. So let me show you where that is. So this is the playing card data set. So we have validation, training, and test data sets. So we have labels and we have images for each of these labels. So like we have seen before in our PPE project, it is the same format, and the thing that is different is again the data.yml file. So let's open that up in a text editor and let's see what changes have we made there. So this is our data.yml file, and here you can see we have number of classes as 52, and all of these classes are based on the rank and the suit. So here it's 10 of clubs, 10 of diamond, for example. So all of these, as you can see, we have here, and then we have the training, validation, and test folders, but we also have defined the path. So the path is drive, my drive, data sets, and playing cards fixed. So they had an issue earlier where they had a duplicate. So I believe it's fixed now. Earlier they had 53 classes because there was a duplicate, but now it's fixed, so I had to upload it again and use this as playing cards fixed. So this is what we have, and then what we do next, what I did next is actually to save some time, I ran the exact same Google Colab. So you check the NVIDIA driver or the NVIDIA graphics card, and we have the similar one that we had earlier, which is Tesla T4. It is 16 GB of memory, and then we install Ultralytics, and after that we import YOLO from Ultralytics. And this you don't have to perform, just to make sure it's running. You can do that, and then you start the training process. So in the training process, all you have to do is you have to change the data path. So it will be content drive, my drive, datasets, playing cards fixed slash data.yaml. So this is what we have to do, and we will have 50 epochs. So right now it's taking a long time. So meanwhile it's training, we are going to go ahead and understand the basic concepts of poker and how we can create a classifier for poker. So that part does not involve object detection, but it is quite crucial to the project. So we'll first go through that. Meanwhile, this will finish what do you call training, and then we can take the data and start the detection as well. So this is up and running, and by the way, this is the data.yml file. You can see it's here as well, so that's good. So let's go back and try to understand what exactly is a poker game and how we can create a classifier for it. So to do that, I've created a simple poker hands classifier, or you can see this is the data sheet or the cheat sheet. So we have a total of 10 different classes. So high card, pair, two pair, three of a kind, and so on. So we will start by understanding that first of all, you have to compare 5 cards. So everyone has 2 cards and the rest are laid out in public domain. So everyone has access to those cards that are in public domain, but the 2 cards that you have are only for you to view. So what you have to do is you have to check your 2 cards and you have to check the rest of the cards that are in public domain to find the best possible scenario. So the biggest hand. So whenever we have these 5 cards, we call it a hand. So we have a total of 10 types of hands, and to understand these, we need to understand what is rank and what is suit. So in poker or in playing cards, we actually have, for example, this is an A of hearts. This is a queen of clubs. So A is basically the rank and hearts is basically the suit. So 5 is a rank and clubs is a suit. So similarly, we have 7 as the rank and diamond as the suit. So what we need to do is we need to understand that first of all, we will differentiate these two. Some hands are based on just the ranks and some hands are based on just the suits, and some of them are a combination. So let's start with the easiest one, which is a pair. We will get to the high card later on, but let's start with the pair. The pair, you have same rank of 2 cards. So the rest of them, they don't match, but 2 of them, they match. So it can be 2-2, it can be 5-5, it can be 7-7, it can be AA. So whatever the card is, you should have a pair of the rank, not the suit of the rank. So for example, you can see this is a pair of suit, but that does not count. So you don't have a pair of suit, you only have a pair of rank. Okay, then we have 2 pair. 2 pair is similar to 1 pair, instead that you have 2 of them instead of 1. So you have a king king and a 5-5. So that's 2 pair. Then you have 3 of a kind. In 3 of a kind, you have 3 of the same ranks. So it can be 7-7-7, 8-8-8, king king king, queen queen queen, or 10-10-10 in this case. The other 2, they don't matter. Then you have a straight. In straight, you have consecutive numbers. So for example, 7, 8, 9, 10, jack. Now here, again, the rank matters, not the suit. We are not looking at the suits at all till this point. So for example, you have 2, 3, 4, 5, 6. That is also a straight. Then you have 7, 8, 9, 10, jack. Then you can also have 9, 10, jack, queen, king. That is also a straight. So you should have consecutive ranks. So if you do 7 plus 1, that should be the next one, 8. plus 1, 9. So that's the idea. By the way, the rank for Jack is 11. So after 10, you have Jack, Queen, King, and Ace. So Jack is 11, rank number 11. Queen is 12, King is 13, A is 14. So that's the biggest rank. Okay, after straight, now comes the suits. So if you have all the same suits, then you have a flush. So it can be all diamonds, it can be all hearts, it can be all clubs, all spades, whatever it is. If all of them or 5 of them are of the same suit, then it is a flush. Then you have a full house. In full house, you have 3 of a kind, which is you have 3 cards that are of the same rank. And then you have a pair. So you have 2, 2, 2, and then 10, 10. It can be 5, 5, 5, and 7, 7. So 3 of a kind plus a single pair, that is your full house. Then you have 4 of a kind, which is very simple. You have 4 of the same ranks. So 5, 5, 5, 5, 7, 7, 7, 7, 9, 9, 9, 9, king, 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 and so on. So the ranks are pretty much the same. Again, we don't care about the suits. Actually, the suits, you will have all the suits. So it's obvious. And the last card, we don't care about the last card. Okay. Then we have a straight flush. In the straight flush, we have a straight and a flush. So we have the ranks and we have the suits as well. So the suits, as you can see, all of them are clubs, and the straight is 8, 9, 10, Jack, Queen. Again, it can be 2, 3, 4, 5, 6, or any other formation, but it also has to have the suits as the same. And the last one, which is the highest one, it is that you have a straight, but starting from ace. So ace, king, queen, Jack, 10. So that is the highest straight, plus you have a flush. So that is a royal flush. So you have, for example, hearts, 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 and then you have a king, queen, Jack. If it starts from queen, or if it starts from king, king, queen, Jack, 10, 9, no, it's not a royal flush. In that case, it is simply a straight or a flush. So, sorry, straight flush. In that case, it's a straight flush. So that is the basic idea. And the last one, if you don't have any combination, then you have the highest card. So the biggest card. So for example, if somebody had a pair and you had the highest card, the pair will win. So with the high card, if both of you don't have anything, like there are 2 players playing against each other, your 5 cards versus their 5 cards, if both of them have no classes at all, none of them, then you check which one has the highest card. So if you have the king and the other one has queen, then you win. So that's the idea. So what we will do is we will classify one hand. So we'll not do 2 hands. We'll do just one hand of our own hand. So we will send in 5 values as strings, and it will output us the name of the hand. So that will be interesting to accomplish. So we will keep this image open, and I will put it on the side, and we will come back to it every now and then. So let's start by creating the folder, and we are going to call it project 4 poker hand detector. So poker hand detector, we're going to start off with that. Okay, so what we will do is we will create a function, and this function, we will input it 5 strings, or you can say a list with 5 strings, and it will output us the result. So we will create it as a module so that it is a separate code in a separate file, and we can simply link it to our project. So here we will create a new Python file, and we will call it poker hand detector function, let's call it. So here we are going to write def find poker hand. So that's how you write what do you call a function, and we have to return something, and right now we will return 0. Okay, so that's good. And then what we have to do is we will be testing it as well. So we need to make sure that we run this individually, and then we will integrate it to our project. So we will write if underscore underscore name equals underscore underscore main. So this means that it is checking if this is the main file that is running, then it will run this code. If some other file is calling this function, it will not run this code. So yeah, we have to put double equal. There you go. So now what we can do is we can send in a few, what do you call, hands. So let's start off. So here is our image. So let's start off by creating all these hands, and one by one we are going to send it to see what it gives. So first of all, let's start. We are going to start at the top. We'll start with royal flush. So A of hearts, K of hearts, queen, and so on. So here we will write find poker hand, and we will send in a list, and inside the list we will give A of hearts, then K of hearts, then we will give queen of hearts, then we will give jack of hearts, and then we are going to give 10 of hearts. So this will be our royal flush, and in front of it we are going to write royal flush, and then we will copy this and we are going to paste. And then the second one we will do is straight flush. So again, queen, jack, 10, 9, 8, but all of them are clubs. So queen of club, then jack of club, then 10 of club, 9 of club, and 8 of club. So this is not a royal flush, it is a straight, S-T-R-A-I-G-H-T, straight flush. So these are the two that we are starting off with. So let's run that and see what do we get. So no, actually no, we'll get nothing. So what we have to do is we have to return, let's return, we will put here hand, and we will return the hand. Okay, or no, we'll not return the hand, we want to print it. So we will print the hand. Okay, so let's run that and see what do we get. No, we are running the previous one. Right click and run, and there you go. So now we are getting this, these two as the output. So that's good. We have started, and the first thing we will do is we will find the ranks and we'll find the suits individually and put them in a list, because what we are trying to do is we are trying to understand, some of them we will classify based on ranks, some of them classifying based on suits. So if we have them in a list, we can play around with them very easily. So that will be our first step. We need to make sure that we have the ranks and the suits all in two different lists. So here we will write ranks equals a list, and then suits equals a list. So these are the two lists that we have, and we are going to loop through the hand, and for card in hand we are going to loop through the card. And first of all, what we can do is, if I wanted the rank, for example, I want the rank which is the first element here. So all I have to do is I have to say card at 0, right? So let me print that out. So if I write that, that will be my rank. So I'm getting A, I'm getting K, queen, jack, 1, and all that. So basically I'm getting what I need. But if you look at the last one, I'm getting 1. That's wrong. That's not the actual rank. So what I can do is I can put an if statement that if the digits are 3, then it means it is a 10. Okay, so then I will take 2 values instead of 1. So I need to get 0 and I need to get till 1. Sorry, till 2, because that's not inclusive. So then I will get 10. But for the rest of them, I should not get 2. I should get only 1. So that's the idea. So I have to check here if the length of card equals 2, or should we write, yeah, equals 2, then it will be rank equals card at 0, else rank equals card at 0 to 2. So now if we print the rank, then it will show us. So for a, king, queen, jack, it's fine, it's getting 1, and for 10 it is getting 2. So that's the idea. So for 8, 9, it's fine. For 10 it is getting the 2. That is exactly what we needed. So this way we are basically getting the rank, and we also need the suits. So if the card has the length of 2, then the suit is the next value, right? So the suits equals card at 1. But if that's not the case, then the suit is basically card at 2. So 0, 1, 2. So that's the idea. And now we will have the rank and the suit. So they will be separately detected. There you go. So A of hearts, king of hearts, queen of hearts, 10 of hearts, and so on. So now we have it separately. So all we have to do now is we have to append it to our list. So here we will say ranks dot append rank and suits dot append suit. And we have to do it for each card. So this should be inside. And we can remove that. So once that is done, just to make sure we are headed in the right direction, we will print the ranks. This will be a list of ranks. And then we will also print suits. There you go. So we have the list of ranks and we have the list of suits. We have the list of ranks. We have the list of suits. So that's good. So now, first of all, we are going to start off by royal flush. So here we are going to check for royal flush, and we'll check the rest later on. Now, how can we check for royal flush? In royal flush, the first thing we need to check is whether it is a flush or not. If all of them are same, in the suits, then it is a flush. So how can you do that? So basically what you can do is you can check if, or let me just print it so that it's easier to see actually what is happening. So what we can do is we can check for the suits dot count the first element. Okay, it can be anything, because all of them have to be same in order for this to be true. So you can pick any element from the list. So you can write suits at 0. So basically we are asking it to count the number of times you are getting this element. So for example, it will take H and it will count how many times we have H in this list. If that is equal to 5, then it means all of them are, it's a flush. Then all of them are the same, then it's a flush. So let's run it. So in the first one, it's true. And in the second one, it's also true. But let's put another hand, poker hand. We are going to put, let's say, we will put another hand. Let's put 4 of a kind, which is next. So it is 5, 5, 5, 5, and queen. So it is 5 of club, 5 of spade, 5 of hearts, 5 of diamond, and we have queen of hearts. Queen of hearts. So this is, what is it? 4 of a kind. So in that case, it will give us a false because all of them are not same. So the last one, it is giving us false because it is not a flush. So this is only checking for a flush. By the way, the next one, no, the one after that is a flush. So let's put a flush as well. So we'll have another one. So let's just put full house as well. We'll put full house and flush, both of them. So these are 2, 2, 2, 2, and 10, 10. So 2 of, so I'm writing it exactly like it is so that there is no confusion of what we are doing. 2 of diamonds and 2 of spade, 2 of spade, 2 of spade. What is this? Why is that like this? It should be hearts, not club. Okay, 2 of spade and then 10 of hearts and then 10 of spade, club. There you go. So this one is, what is it? Full house. Full house. And the next one will be flush. So in flush you have I'm using again the same one, 2 of diamonds. Then all of them, they will be diamonds. So this will be king of diamonds. This is 7 of diamond. Then we have 6 of diamond, 6 of diamond, and 5 of diamond. 5 of diamond. So let's run that. It's giving us a lot of outputs. So let's not print the hand and let's not print the ranks and suits. And we run that, and there you go. So the first one has a flush, so it's true. The second one is also a straight flush, so it's true. The third one is 4 of a kind, so it's false. The fourth one is also false because it's a full house. And then we also have another flush, so it's true. So this means this methodology will first of all tell us whether it's a flush or not. So we can check for royal flush, and we can check for straight flush, and we can also check for flush. So we can check 3 of these things right away. So if we go in, if we have this first condition, if that is true, it means it is a flush. Now, once we know it is a flush, we can get to the second step, checking whether it's a royal flush or not. So in the royal flush, we must have the ranks. So, but the thing is that it might be A of hearts, king of hearts, but it might be sorted wrong. So we need to make sure, first of all, that they are sorted properly. So the biggest one, the highest rank, should be the first. But A, king, queen does not have a rank yet. Because if we print it out, if we print out the ranks, let's just write pass here. If we print out the ranks, it will not give us for A, king, and queen. It's simply writing A, king, queen, jack, which is wrong in our case, because we need to work with values. When we sort them out, we want 14 to be A instead of just writing A. Otherwise, it will not be organized, because if I remove A here and I put A here, then it will give us K first and A second, which is still a royal flush, but it's not in sequence, so we are not able to get the rank properly. So what we'll do here, we'll simply write if rank equals A, then rank equals 14. That's how simple it is. So else if rank equals king, we'll copy that, paste and paste. Okay, so rank is A, rank will be 14, rank is K, it will be 13, rank is Q, it will be 12, rank is Jack, it will be 11. There you go. So now if we run it, we will have numbers. So 13, 14, 12, 11, 10. Now what we need to make sure is that they are sorted properly. If they're sorted properly, then it will be easier for us to check for royal flush. So what we can do is we can simply write sorted. So sorted ranks, actually we will do it after the sorted ranks equals sorted, and we will give in our ranks. That's it. So if we print ranks again, you will see that now it will be sorted. Okay, so ranks, when we are sending them in, they are not integers, they are strings, so we need to convert it into integers. There you go. So now you will see, actually it didn't do anything. Why is that? Oh, because we printed ranks, not sorted ranks. Okay, let's run that again, and you will see for the first one, you will see this one is 13, 14, 12, but now you can see it's 10, 11, 12, 13, 14. So it has sorted it. So now what we can do is, actually, let's forget about the sorted rank, because, or we can use the sorted ranks, but what we can do is, instead of saying that the first one is 10 and the second one is 11, we can just say if it's in this. That should work as well. So we can write if 14 in sorted ranks, and so that's how you can check if 14 is present in the sorted ranks, and then we will write another and, then another and, then we will write another and then another and. So if 14 is there, then 13 is there, then 12 is there, then 11 is there, and then 10 is there. I wrote one extra. If that is the case, then it means it is a royal flush. So we will print royal flush. So let's run that, and there you go. So here you can see it says royal flush, because this is true for this, the rest of them it's not true. So what we will do is, in order to get the output, we are going to say we are going to create a list called possible ranks, and this list will contain all the possible ranks. So if, for example, we are getting a royal flush, we are going to put the value of 10 inside it. We are going to append, because sometimes what you can have, we can also detect a single pair when it's two pair, right? So we need to find the highest one. So we will put all the possible scenarios inside this list, and we will pick the highest one. So if it was, for example, if it detected that it is a 3 of a kind, and it also detected it is a full house, then for full house it will be 7, and for 3 of a kind it will be 4. So we will pick 7, and that will be our highest hand. So that's what we are going to do. So in this case, our royal flush is 10. So we are going to put inside here, we are going to write possible ranks dot append 10. So we are going to append that. And once we do that, in the return, we are going to return the possible ranks maximum value. So that's the basic idea. Or should we return? No, that will return only a number. Wait, what we can do is we can write the poker hand ranks equals, we are going to create a dictionary, and for each one of them we are going to give a number and a name. So it will be royal flush. Then for the second one, for number 9, it will be straight flush. And for number 8 will be 4 of a kind. Then for number 7, it will be full house. Then for number 6, it will be flush. Then for number 5, it will be straight. GHT. And then for number 4, it will be 3 of a kind. Then for number 3, it will be 2 pair. For number 2, it will be pair. For number 1, it will be high card. So these are all our ranks. And now what we can do is we can check the max possible, and then we can write here poker ranks at this value. So we will return that, and we can simply print that out. So here for each one of them, we can simply write print. There you go. So now let's remove all the prints, and what we will do is, or should we print here? No, let's not print here. Let's print it inside, so we'll not have to write it again. So we will print the hand, and we will print what it is. Like, what did it detect? So here, print hand, and print this. Or let's give it, let's call it output is this, and then print the output, and then put the output here. Return the output. There you go. So yeah, let's run that and see what we get. Max argument is an empty sequence. So the first one, you can see it is a royal flush. So it is returning that. If nothing is there, if there are no, we can simply write if not possible ranks. It means if possible ranks is empty, then possible ranks dot append 1. It means it is high card, right? If we have not actually coded for the flush or the straight or full house, for now it will just say high card. So as we go along and we keep adding, it will keep fixing. So for now, you can see it says royal flush for the first one. For the second, third, fourth, and fifth, it says high card. So now we are heading in the right direction. We are getting a good output. We can see the results. And here we are checking for this sorted ranks. Let's keep it for now. Maybe we will need it later, but actually we don't really need it for now. So once we check that, if this is the case, the second one we are going to check is for straight flush. So if we know how to check for straight, we can just put the straight code inside this if statement and it will become straight flush, because this statement is checking for flush. Because if we write here else possible dot append is what is flush is number 6. So we'll put here 6, and if we run this now, you will see that this one is detected as a flush and this one is detected as a flush. So this one is correct, it's a flush, but this one is a straight flush. So we need to fix that. We need to add another if statement here to check for straight. How do you check for straight? Let's do that first. So here we are going to write straight. Okay, so what happens is, in order to check for straight, now we need the sorted ranks. So for example, we will have in the sorted ranks, we will have, let's say 10, 11, 12, 13, 14. So this is our sorted ranks. So what can we do? We can take the first element, or we can take this element, and we can say, check the element before this and add 1 to it. So right now we are talking about 11. We will take 11, and then we will take the element before this, which will be 10, and we will write here 10, and we will say that add 1 to that element, plus 1, and check if they both are equal. So then it will become 11 equals 11. So that is true. Then it will go to the next element. So it will go to 12. Then it will check the one before it. It will be 11. So it will write 11 and it will add plus 1. So it will check if 11 plus 1 is 12. If that is true, it will become true. So we will keep checking for all of them. So if all of them give us true, then we will say, okay, it's a straight. If even one of them gives us something else, for example, this one is, let's say, 7. So we write here 11 and it checks 7 plus 1 is 8. This one is false, but the rest of them are true. Then it's not a straight. So that's how we will check it. So to do that, we are going to write some efficient code. So we are going to write for I in range. So we are basically looping and we need to loop through 1 because we are starting off. Actually, let me put it back, because we are starting off with this value, not this value. We will pick this value and add 1 to it. Add 1 to the previous one, because this value does not have a previous value. So we will start from 1 and not 0. So here we are going to write for I in range 1 till the length of our sorted ranks. It will be 5, so it should be fine. But we are still writing it. So if that is the case, so to make it a little more efficient, we are going to write a single line for loop. So instead of writing it after, we will write it before that. So what exactly are we writing? We are writing that sorted ranks at I. So sorted ranks at I, not 1. Sorted ranks at I. So this will be, for example, 11. This is equal to sorted ranks at I minus 1 plus 1. So this is what we are doing. We are putting 11 equals 10 plus 1, right? If that is the case, and what we can do is we will keep getting the answer and all of this will be stored in a list. So in that list, we can just write here all. If all of them are true, then it will give us true. If even one of them is false, it will give us false. So that's the basic idea. So we need to put another bracket here, and we will put an if statement. Or is there a problem? 1, 2, 2, 3. Okay, there should not be a bracket here. Okay, so that's the idea. Let me comment this as well. Let me put this as well here so that you understand what exactly happened. So if that is true, it means it is a straight. So we can write possible ranks dot append. What is a straight? A straight is number 5. Number 5. Did we add a straight so far? No. Actually, let's add all of them, because that's annoying, you know, going back and forth. So after flush, we have straight. We have straight, then 3 of a kind, 2 pair, pair, and high card. So flush, then we have straight, then we have 3 of a kind, then we have 2 pair, then we have pair, and then we have high card. There you go. So now we did till flush. Now we are going to do straight. So for straight, we have jack of spades, clubs, jack of club. Then we have 10 of hearts. Then we have 9 of club. Then we have 8 of club. And then we have 7 of diamond. So this is our straight. And then poker hand, 3 of a kind. We have 10 of hearts, 10 of hearts, then 10 of spades, 10 of spades, or is it? No, it's not spade, it's club, my bad. 10 of clubs, and then 10 of diamonds. 10 of diamonds, and then 2 of diamonds. 2 of diamonds, and then 5 of spades. Then 2 pair, we have king of diamond. Then we have king of hearts. Then we have 5 of clubs. Then we have 5 of spade. And then we have 6 of diamond. Then we have a pair. We have 2 of diamond, 2 of what is it? Spades. Then we have 9 of clubs, and we have king of diamond. Then we have 10 of clubs. The last one is king of diamonds. So king of diamonds, 5 of diamonds, then 2 of diamond. Oh, 5 of hearts, my bad. 5 of hearts, 2 of diamond, and then 10 of clubs, and then jack of diamonds, jack of hearts. I'm getting mixed up now. Okay, so that's the idea. And now let's run it and see what you will get. So we should have the correct straight. So if we run this now, for straight, this is straight. It is jack, 10, 9, 8, 7, and it is correct. So this is straight. Now what we need to do is we need to take this straight part and we need to add it to our if statement here. So we will put else if. So first it will check if it's a flush, and then it will check if it is a straight, then it will become straight flush. So straight flush is number 9. So you can see here, this is straight flush. So it will become number 9. So if we run that now, over here we have the royal flush. It's fine. The straight flush is now being detected as well. So that's very good. So we have the straight flush here. Okay, so we have done 1, 2, 3 and 4. So we have done 4, and we have also done the 5th, which is the high card. So we have done 5 out of 10. So we are halfway done. Now what we will do is we are going to check for 4 of a kind, then we will check for 3 of a kind, then 2 pair, and then a single pair. So to understand how can we check for, why is it showing a search? Let's remove that. Okay, so to check, let's do it after straight. This is 4 of a kind. Now 4 of a kind, if you have a list, right, 4 of a kind will have 4 of them as the same and 1 card will be different. So for example, you will have 3, 3, 3, 3, and then 5. So 4 of them are same and 1 of them is different, right? So what we can do is we can tell the computer to create a set. What does a set do? A set will put all these 3 together and it will put this as separate. So when you do a set to this, this will become 3 and 5. So we can check how many do we have. We have 3 and 5. So after completing the set, how many values do we have? If we have 2 values, this means it might be 4 of a kind, because there is another condition where you can have 2 set. And that is when you have, let's say, 3, 3, 3, 3, 3, 3, and 5, 5. So in that case, if you do a set, then also it will give you 3 and 5. So we need to check, first of all, whether when we convert it into a set, does it give us 2 values? If that is 2, then we need to check whether this value comes 3 times or 4 times. If it comes 3 times, then it is 4 of a kind. If it comes 3 times, then it is full house, because these are 3 of a kind, and this is a pair. So it becomes full house. So how can we do that? First of all, what we will do is we will get unique values. So hand unique values equals set of sorted ranks. But this will be a set. You cannot use it as a list, so we will convert it into a list to make it easier for us to work with. So we will do that. So if I print unique hands now, print unique, hand unique values. So let's print that, and for each hand it will print the unique values. So for the first one, there are no unique values, so 8, 9, 10, 11, 12, so it's printing that. For the second one, again, the first one was here. The second one, no unique values. In the third one, you have unique values. So you have 5, 5, 5. It's 3 of them. 4 of them are 5. So it's giving us 5. And 1 of them is a 12. So it's giving us 12 and 5. So this one is basically 4 of a kind. And after 4 of a kind, we have a full house. So that is also giving us 2. So it was giving us 2 and 10. So these are 3 and this is 2. So now we need to check if the unique hand list basically has 2 values. So first of all, we need to check if it has 2 values. If the length of hands unique values equals 2, if that is the case, then it will be one of these, 4 of a kind or full house. Actually, we should put this here somewhere, but it's okay. I think we should put this one outside, because this one is journal. It will also be used for 3 of a kind. It will also be used for full house, for 2 pair, and so on, because this is unique values. So now we are checking for 4 of a kind. So now what we will do is we are going to check, we are going to loop through all the values. For value in hand unique values, so it will loop through the values which will be 12 and 5. Okay, so for each value we need to count how many times is it present in our complete list. So we will say that how many times the value of, let's say, 3 is present in this whole list. We need to check that. So we will say that sorted ranks dot count. So this is our sorted list. Where is it? This sorted list is basically 8, 9, 10, 11, 12, or in this case it is 5, 5, 5, 5, 5 Q, right? Or queen is 13. No, it's 12. So it's 5, 5, 5, and then 12. So that's our sorted. So we are going to check this value, how many times does it come in the main list. So we will write here val, and if that comes 4 times, then we are going to write, we need to write if that is the case, then we will write possible rank dot append. What is 4 of a kind? 4 of a kind is number 8. So we will append 8. And if it is not 4 times, if it's 3 times, then it means it is number 7, which is full house. If it's 3 times and the set is 2, this is a unique value, this is a unique value, the set is 2, and one of them is 3, it means the other one will be 2 automatically. So we know that if it's 3, then the rank is 7. So if we run this now, you will see that here we have the royal flush, straight, 4 of a kind. It's detected properly. This is 4 of a kind. There you go. And then if we have a full house, it is also detected properly. Oh, sorry, this is full house. This is 4 of a kind. So here we have 2 and 10. So this is full house and this is 4 of a kind. There you go. And already we have the flush and the straight working. So that's good. So the same pattern we are going to use with the next one, which is 3 of a kind. So here we have done the flush, we have done the straight. Now we are going to 3 of a kind. So now we are going to 3 of a kind and 2 pair. So if, let's say, we have a 3 of a kind, so we will have 5, 5, 5, 5, and 5, and we will have, let's say, 6 and 7. Because if we have 6, 6, it becomes a full house. We are not talking about that, right? We are not talking about that because we have already done that. So if it's 6 and 7, then it will give us how many unique values? It will give us 3 unique values, because when we send it to a set, the set will be 5, 6, and 7. So it will give us 3 values. We can also have 3 values in another scenario. What is that scenario? Where you have, let's say, 8, 8. This is a pair. Then you have 7, 7. That's also a pair. And then you have 3, let's say, or let's say 2. So when you create a set of this, so you will have 8, 7, and 2. So how many unique values you have? Unique values are 3. Also here, unique values equals 3. So in both cases, it's 3. In this case, it is 3 of a kind. And in this case, it is 2 pair, right? So we need to check, first of all, if they are 3. Actually, we can write here as well, unique values are 2 and unique values are 2. There you go. So 4 of a kind, full house, and that. Okay, so here we need to check if the length of unique values is basically 3. So here we are checking 4 of a kind and full house. Here we will be checking 3 of a kind and pair. There you go. So for both of them, we first need to check the unique values. There are 3. Then we will check the values. If the value comes how many times? We will loop through the value, and if the value comes, so here the value will come 3 times. So if the value comes 3 times, then it is a 3 of a kind. So a 3 of a kind is 10. Not 10, it's 4. So 3 of a kind is 4. And if the value comes 2 times, which means here, for example, is 2, and here, for example, it's 2, then it is a 2 pair, which is 3. There you go. Sorry, when it comes 2 times. So if it's 3 times, it is 3 of a kind. If it's 2 times, it is 2 pair. We can write it here as well. So it's easier to know what's going on. Here also we can write 4 of a kind, and this one is full house. So it's pretty easy. All you have to do is just think a little bit. How exactly can we do this? And I believe only one is left. Let's run this first. And there you go. This is 3 of a kind because we have 10, 10, and 10. And the other 2 are different. So it's not a full house, it's 3 of a kind. And actually, let's change it to full house. Here, 3 of a kind will make it full house. If we write here 10 as well, let's see if it detects as a full house. There you go. So where is it? Full house, there you go. No, full house is here. And then it's a 4 of a kind. Sorry, I made it 4 of a kind, my bad. I wanted to make it full house, which means this is 2D. So this will be also 2D, my bad. So this will become a full house. There you go. See, now it's a full house. It means our methodology is working fine. So we have 3 of a kind working properly. Then we have 2 pair. So king, king is working fine. 5, 5, that is a 2 pair. Excellent. So now we have these unique values. And then the last one is very simple. We are checking for a pair. Pair is simply when you have 4 values. So for example, you have, let me share an example here. So you have 5, 5, and then 3, 6, 7, and 8. So the set of this, did I write more values? I think, yeah. So the set for this will be 5, 5, will be 5, 3, 5, 3, 6, and 7, which are 4 unique values equals 4, which means a pair. That's how simple it is. So you will simply write possible rank dot append, and you will write 2 because 1 is already there, and that is your high card. So if we run this now and we go down, and there you go. So here you're getting a pair, here you're getting a high card. So this is basically how we can get these values. So to repeat or to summarize what we have done, we have first of all extracted the ranks and the suits, and we have created a variable called possible ranks, not a variable, a list in which we will store all those ranks. Actually, let's print out the possible ranks before we print possible ranks, and let's see if there are more than one. Yeah, here you can see it's 3, 3. Both of them are 3, so it's 9 and 5. So it is also a flush and it is also a straight. So and then it is both of them together, so it's straight flush. And then here you have four of a kind. So the rest of them, they don't have multiples, but this one has multiple as well, because it is a flush as well, and it is a royal flush as well. So it will take the bigger one, which is royal flush. So yeah, that's the idea. And then as we were mentioning, so you extract all the ranks and all the suits. Once you have them in lists, you sort them, because sorting them will make it easier, especially when you are finding the straight. That will make it much easier. So you will first check for the royal flush. No, you will first check for the flush. So check, let me write here, check for flush, and then it will check for royal flush over here, and then it will check for straight. If it is flush and it is royal, then it will be royal flush. If it's flush and it is straight, then it is straight flush. Otherwise, it will be simply flush. So this is flush basically. Then we have straight. In straight, what we are doing is we are checking the previous value and we are adding 1 to it and comparing it with our current value. So 11 is being compared with 10 plus 1, 12 is being compared with 11 plus 1. If all of them give us true value, if they are same, then it becomes all of them are consecutively listed and ranked. So that's why we will write it as straight. Then comes the unique values. So we will check the unique values by putting a set to the sorted ranks. If the unique values are 2, it can have 2 possibilities, 4 of a kind or full house. If one of the values has 4 counts, then it is a 4 of a kind. If one of the values has 3 counts, then it is full house. Same way we are checking the unique values, and if the unique values are 3, there are 2 possibilities. One of them is 3 of a kind if the value has the count of 3, and if the value has a count of 2, it means it's 2 pair. And then if it's single pair, then the unique values, the set will have a count of 4. And if nothing else works out, then it is high card. And once all of that is done, we have our dictionary with all the rankings and the numbers, and then from that we extract what output do we get, what is our result. So let me remove all the prints so that it is neat and clean. We don't want too many things printed. Yeah, so then we only have the hand and what it is detected as. So royal flush, straight flush, 4 of a kind, 2 pair, and so on. So this is basically how we can classify our poker hand. And now once we have written this code, now we can go and use our trained model to detect that hand, and then we will send it to our find poker hand, and it will give us the output of what type of hand it is. So let's go ahead and do that. Okay, so now our process has been completed. The training is done, and we had 50 epochs completed in 7.5 hours. So for further details, you can look at the precision and recall curves, and we also have the confusion matrix and all these training and validation batches. So what we will do now is we'll download the best one, and we are going to use that in our project. So we already have project 4 listed, and we have created our poker hand function. And now what we will do is we will copy YOLO webcam, because we'll be using our webcam to run it. So we'll simply copy that and we will name it poker hand detector. So once we have that, we will bring in our model. So here you can see this is best 7. So let's drag that in, and we will call it playing cards .pt. And over here, now we have to make the changes so that it detects these. So first of all, the class names we need to change. So to change that, we can go back to our data.yml file, and we can copy all the names, and we can simply paste them here, and we can just cut this and paste it here. There you go. So to make it easier to understand what's going on, and we have all the classes, we can simply press enter after each of the ranks are done. So after 2 is done, then 3, 4, 5, 6, 7, 8, 9, ace, jack, king, and queen. So as you can see, we have all the classes listed here, and the video, we are not going to use any video, so we can remove that, and we can open up the webcam, and we will be using webcam 1, and this is the size, and we will be using our own weight, which is playing cards.pt. And let's run this now and see if it works. So I have my webcam upside down, and we have some playing cards here, and we are going to test them out one by one and see how it performs. Once we know that all of these are detected properly, we can go ahead and merge our poker hand function with it so that we don't have any issues. So let's see if that works. It's actually running at the background. So here, let's put in 2. There you go. We are getting 2H, which is basically 2 of hearts. Then we have jack of clubs. That's good. We have queen of spades. That's good. So in order to make it a little bit more efficient, what we can do is we can put all of the 2s together and see if they work fine. There you go. 2 of diamond, 2 of clubs, 2 of spades, and 2 of hearts. So we are detecting them properly. That's good. Then we have the clubs, the 3s. Let's try those. And 3 of diamond, 3 of club, 3 of heart, 3 of spades. That's working fine as well. We have to do this to make sure everything is working fine. There might be 1 or 2 classes that are not detected properly, so we have to make sure all of them are correct. Heart, spades, diamond, and clubs. So those are fine as well. So far it is giving us really good results, and it's very fast as well, as you can see. So this is 5 of spade, 5 of diamond, heart, and club. There you go. Then let's check the 6. Let's put them like that. Diamond, club, heart, and spade. That's fine. Then let's put 7. Let's try it like that. 7, all of them are correct. Let's try 8. 8, all of them are correct. 9. Yep, all of them are correct. 10. Yep, correct. Then we have jack. Yep, correct. Then let's try the queen. Yep, correct. Let's try the kings. Wait, I'm missing a king. Oh, what happened? I am missing a king. Okay, so let's just try with the cards we have. Oh no, I found it. Never mind. Okay, club, heart, spade, diamond. Excellent. And now the moment of truth, the last one, the ace. Ace of spade, heart, club, and diamond. Perfect. So we have 100 out of 100 being detected. properly. Actually 52 out of 52. So what we will do now is, once we detect, first of all, we are already displaying it. We are going to put it in a variable called hands, or hand. Hand is equal to empty. Now, once we have this, we are going to send this hand to our poker hand function. So here, if we import, now in order to import this, we'll have to rename it, rename file, and we will write it poker hand function without the dashes so that it's easily imported. So we'll write here from poker. So we can write here import poker hand function. So now we will have the ability to use find poker hand. So we can go down here and we can send it to find. So we can write poker hand function dot find poker hand, and we will send in our hand. So we will check the results equal this. And what we have to do is we have to first of all make sure that we have 5 different cards. So if there are 4 or 2 or 3, then it should not work. So we should have a total of 5. So if the length of hands, if the length of hand equals 5, then only we are going to send this. If it's more or less, we should not send it. So once that is done, we can simply print the results. We can display it. We will display it now, but for now we'll do that. Okay, so once we are actually detecting this, we can put, for example, a limitation that if the confidence level is greater than 0.5, then hand dot append, we are going to append the class name. So the class name is basically CLS. So this is not actually the class name. The class name is class names of CLS. There you go. So we will append that. So what we can do is we can print hand. So let's try that out and see how it works, because we want to see what exactly are we sending before we actually see the results. So let's put 2 cards in and let's see what result do we get. So there you go. We have some results here. So there you go. It is appending. It keeps adding to it, which is not good. The hand should be, after each iteration, it should update and it should clear out. So we need to have a fresh start every time it runs an iteration. So there you go. We have these AS, AH, and AH. AS, AH, and AH. Okay, so the problem here is that it's showing it twice. So that's not good. So what we need to do is we need to create a set and send it back to a list. So this way it will only have unique values, because we cannot have 2 of the same cards. It cannot be possible. So we can simply just do a set and then it should work fine. So here we can write hand equals set of hand, and then we can put it in a list again. And we will print it before and we will print it after. So there you go. So if this is the case, then the set is like this. So we are getting 1 of each. So that's good. That's exactly what we want. So as you can see here, it is detecting, but we are getting 1 of them. Okay. So now what we can do is we can add 5 of these and it should give us the result. So let's put 4 of a kind, because it's really easy here. I have already A's lined up. and we have these ace, and then we can add simply another card, which is a king, and we should get an output here. So let's go at the end and let's see. So there you go. We are getting 4 of a kind. So the moment of truth has been revealed and we're getting a 4 of a kind. Excellent. So that is really amazing to see how it works. Now what we can do is we can simply put it on display so that we can see it in real time. So here CVZone put text, we can copy that and we can paste it here. And instead of the class name, we'll do the result. Results, and we will write your hand, and we will write it like that. So here we are going to give in the position of 0 and 0, let's say, or should we put it in the middle? Let's do a little bit in the middle. What's the size? 1280, maybe 300, and the height maybe 50, and the scale we want it big, so let's put it at 5, and the thickness let's put it at 6. Hopefully this will give us some good results. Okay, so it's too big. We need to push it down a little bit, and we need to make it a little bit smaller. So maybe 3, and thickness is 5, and we push it down further to 75. Let's run that. There you go. Your hand, 4 of a kind. Excellent. So what if I remove one of the ace and I put a king there? Then it becomes full house. Your hand is a full house. That's excellent. And what if I put, instead of an ace, I put another king, and okay, where's the ace? Okay, I need to remove that. And then I put a random card, let's say 6. Then it should be 2 pair. Excellent. So what we'll do is we'll go one by one and we will test out each of these scenarios. So let's put it together and let's see what do we get. So let me try to put this here. So the first one we are going to do is royal flush. So in which we have ace, then we have of the same type. So we will have the king of diamond, then we have the queen of diamond, and then we have the jack of diamond, and then we have the 10 of diamond. So that should give us royal flush. So there's another card coming in here. Let's put them straight. There you go. So now it should give us the result, but it's not. What is the issue? 10 of diamond, J, D, Q, D, KD, and AD. What seems to be the issue? A, KH, JD, 10D, QD, and KD. So there's a 10D somewhere for some reason. Yeah, there is a 10D. Yeah, 10D is supposed to be there. A, K, J. There's another K, KH. Where is the KH? Oh, okay. So it's detecting it here. My bad. So there was another card on the side. That's why it was detecting that. Okay. So there you go. So you have a royal flush. Excellent. Now let's try a straight flush. So we have, let's say, king, queen, jack, 10. And if we put a 9, 9 of diamond, then it will become a straight flush, because it will not be a royal, it will be a straight flush. There you go. So now it is a straight flush, and let's try 4 of a kind. So we are going to add ace, 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 and a king. So, or a 9. So ace, 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 and where is the other ace? There you go. There you go. Hand 4 of a kind. That's perfect. Then we will try a full house. So we will remove the A and we will put a 9. So that is a full house. Excellent. Now we will try a flush. So let's put all diamonds. So random diamonds. Doesn't have to be straight or anything. So we are going to put 6 and a 5. There you go. And we have another one. So there you go. So even if they are not exactly straight, it will still detect them. So full house. Then we had a flush. The flush is working fine. Now let's try out a straight. So let's try out 5. Then we will try 2, 3, 2, 3. Now we need a 4. We also need a 6. And where is the 4? Come on. Where is the 4? There you go. So we have a 4. So there you go. Your hand is straight. So it's upside down. It's not really organized, but still you're getting a straight. It's not very stable. I'm not sure why. If you push it further, yeah, there you go. Now it's much stable, much more stable. So we're getting a straight. That's perfect. Then we have to try a 3 of a kind. So let's try with queens. So these are 3 queens. And then we have a 2 and a king. So your hand is 3 of a kind. Perfect. Then we have 2 pair. So let's remove the queen and let's add a king. So that will become 2 pair. What happened? There you go. It becomes 2 pair. And then let's try a single pair. There you go. Your hand is a pair. And let's remove the queen. And let's put a 5 here. And that should give us high card. There you go. It gives us high card. So this is basically our project successfully done, and it looks really good. And we are getting real-time output. And let's try it in our hand and see what it gives us. There you go. It gives us high card. So it gives us high card. And let's try it with a pair or something so that we can see if it works properly or not. There you go. So it is a pair. It is a pair. And then let's put another king here. It will become 3 of. There you go. 3 of a kind. 3 of a kind. And then let's make it 4 of a kind. I think it fell down. No. We need another king. Where is the king? There you go. So we'll get 4 of a kind. We have 4 of a kind. And then let's try a flush. So let's make a flush of diamonds. Flush of diamonds. There you go. It's a flush. Excellent. And what else can we try? Let's try a full house. So we have queen, queen, and king, and a king, and we need another queen. There you go. So this should be a full house. Full house. Yep. And if we remove the queen and put, let's say, 2, then it will become 2 pair. There you go. So that's pretty good. So as you can see, our object detection model is working really good, and our poker hand detector is also working very good. So this was our project. As you can see, you can put all these things together and it really creates a great project, and it gives you a lot of information, and it is fun to play around with as well. So object detection is like a superpower. Once you understand how to train your custom models, you can really explore the possibilities and create some really good projects that are very useful in real world applications. So I hope you have learned something here, and I hope you will apply these methods to some good use. If you like this course, give it a thumbs up. If you loved it, share it with your friends, and I will see you in the next one.